Hey everyone, welcome to the show. This is week one for our matriculants, also known as grade 12 learners. Welcome. And we are going to be doing week one work, which are sequences and series. So, if you kind of new to my channel, what I'm trying to do here, I'm just working through the syllabus for the math learners, and yeah, I'm hoping to do this, make this a weekly series. Haha, series. Wow, cringe much. But yeah, so let's just jump straight into work. I do not want to make this video too long, so let's go straight into it. So arithmetic sequences. These are just by definition. We have the definition on the screen at the moment. It's a sequence of numbers in which each term is calculated by adding a constant value to the previous term. The constant value, also known as a common difference. So, yeah, first of all, a sequence is just a list of numbers, right? Where they are in a specific order, so the order does matter, right? So, yeah, like here I have four of them, just to give you a quick example of them. We see that for this first example, we have 2, 6, 10, 14, 18, 22. So they share a common difference. So how would we find a common difference? To get us from 2 to 6, how would we get from 2 to 6? We just add 4, right? Great. And we see that that trend continues throughout. So to get from 10 to 14, we add 4. From 14 to 18, we add 4. So we see that for this sequence, the common difference is 4, right? We're adding 4. Right. Over here, minus 5 to minus 3. How do we get from minus 5 to minus 3? We add 2, and we see that continues over there. So we add 2. Wow, great handwriting again, as always. And then over here, this one would be 3 plus 3, of course. And the last one over here would be, we see we have minus 1 here and 10, so that would be 11. We add 11 to minus 1, we get 10. Add 11 to 10, we get 21. So that would be plus 11. Right? So this is how we recognize a sequence as being arithmetic. Right. So a general equation for the nth term of an arithmetic sequence. So we know that, for instance, this one here, there's a common difference of 4. We know its first term is 2, but then how would we get a general term? So for instance, if we were looking for the 100th term, you wouldn't really want to go adding 4 continuously until you get to the 100th term, right? So we find a general equation to determine any number, any term, any nth number in the sequence, right? So we start off by just listing a few of the important parts in the sequence. So first thing, we can just use the letter A. This will just represent the first number in the sequence, the tn1, if you want to call it. And then we have D. D is our common difference. And N would be our term number. So we see in this first one, this would be term number 1, 2, 3, 4, 5, and 6. And then of course we have our Tn, which is the value at that nth value, at the n value. Cool. So using as our first sequence as an example, in this case, A will be 2, the common difference would be 4, the n value would just be n, because that's what we're looking for, and Tn would just be the answer we're looking for, so that just stays Tn, right? So our general formula, the value of our nth term is going to be equal to, so this will just simply be our first term, which is going to call this A for there, plus our bracket n minus 1 D, right? So if yeah, I can't prove this, but I feel like it's going to take a little too much time, so if you really want me to prove this, I'll gladly do it. So if we look at our first example over here, right? So if we just substitute all our values in from our first sequence, we're going to have Tn equals to A, which is 2, plus N, which stays in, minus 1, and our T, which is 4, right? We can multiply this 4 in, so we're left with 2, so it stays there. 4 times N is just 4 in. 4 minus 1 is minus 4, and then this just gives us 4 in, and then we have 2 minus 4, which gives us minus 2. Right. So let's check our answer. We see this would be our first term, second term, third term, fourth term, fifth term, right? So let's check this this fifth term. So what we're going to do we're going to solve for t at 5, right? T in a 5, which equals to, now using this formula here, we're going to say 4 coming from over there. Now our n value has changed to 5 now, because we just want to confirm that answer. Minus 2. 4 times 5 is 20. Minus 2 is 18, which is true. We can confirm that. And we can do the same for, if you want to do like t of 100, and it will just be 4, 100 minus 2. 100 times 4 is just 400. Oopsie. Minus 2, that just gives us 398. So that would be the value of our 100th term. Coolio, this is still sequences, remember, we're not at series yet. So yeah, let's start with our next sequence, which is geometric. So the difference between a geometric and an arithmetic is that the geometric calculates its new term by multiplying to the previous term, right? So an example of that would be just like 1, oh wait, I have examples here, but yeah, let's just say 1, 3, 9, 27. Because you see, what I did was I just multiplied the first term by 3, and then I multiplied the second term by 3, and then 9 by 3, and so on. So before we were adding a common difference. In this case, we're going to be multiplying common ratio, if you want to put it like that, and that is what we define as a common ratio. So in these examples, just as we did before, we're just gonna determine our common ratio. So to get from 5 to 10, we could add 5, but then notice if we add 5 again, we're not going to get 20. So what we do is, to get from 5 to 10, we multiply by 2, and then 10 to 20, we multiply by 2 again. To get from 20 to 40, we multiply by 2. So we've taken the previous number and then multiplying it by our ratio to give us our new value. So that means that this here is multiplied by 2. To get from a half to a quarter, what do you think we did? We just simply multiplied it by 1 over 2 as well, because notice we multiplied by half or we divided by 2. That's the same thing, right? So what we did, you can say divide by 2 or multiply by a half. It's pretty much the same thing, and that's how we get from a half to 1 over 4 to 1 over 8, right? And we can just continue doing this throughout. You just find your common ratio. The easiest way to do it is just by taking your second term and dividing it by your first term. So for this third example, we have our t2 divided by t1, which is just simply 28 divided by 7. So that's 7, 14, 21, 28, so that gives us 4. So that just means that our common ratio, the notation that we use for it is a lowercase r. So our r, oopsie, that doesn't look nice. So our r value is 4. Right, we can do the same over here. We just say t2 divided by t1 is 6 divided by 2. That gives us 3. Right. So once again, same thing as we did before. We want a general equation to determine our nth term, because let's say, for example, we wanted our 100th or our 200th term. So yeah, things are a bit differently. Yeah, things that we want is still our a term, that is still our first term, but now we don't have a common difference, so we won't use d, we will use r because of our common ratio. And then we still have n for our nth term and our tn for the value of at the nth term. Right, so doing the first one again, the first one, right, yeah, our common ratio was 2. We see that a is 5, common ratio is 2, n stays the same, tn stays the same. Alright, so just as before, our tn value has a general formula, which is just a, starts again with a, multiplied by r to the n minus 1. So that this is our general form. And if we substitute our first one that we wrote on the side, we're going to get tn is equal to a, which is 5, multiplied by the common ratio of 2 to the n minus 1. I can't simplify that any further, so let's test out an example. Let's take the value of, right, this is our first term, second term, third term, fourth. Yeah, let's do fourth term. Let's check out the fourth term. So we're going to take t of 4 is equal to 5 multiplied by 2 to the 4 minus 1. 4 minus 1 is 3, so this still gives us 5 times 2 to the 3. 2 to the 3 is 8, so it's 5 times 8. 5 times 8, and if you check on your calculator, is 40, which is exactly what we have. Right, series. And first thing I'll ask, what is a series? And how does it differ from a sequence? So while in a sequence where we have this ordered numbers, a series is we will take the sum of all those numbers to determine a series of that sequence. Right? Let me just say that again. We're going to take the sum of all the sequences to determine the series. So for instance, let's just use the sequence from before, where we had 2, 6, 10, 14, right? We had 2, 6, 10, 14. So over here, this is a sequence. But what we do to get a series, we will add all of them together. So this would be our Tn, that's the notation we use. For a series, we will use Sn. Right? So the series for, let's consider this point here. Let's say S of 3, right? S of 3, because our nth term here is 3. What we will do, we take 2, because we're taking the sum, we're going to say 2 plus 6 plus 10. Right? And then 2 plus 6 is 8, 8 plus 10 is 18. And then our S of n term is 18 at this point. So that's what a series is. Right. So finite arithmetic series is. So why do we have the word finite in front of you? The word finite just means that there's an end to it, right? Because look at this example. This S of n what ended at um, at 3. This is of 3. So we see that it had to have an end, because if this thing just continued, we'll be have to adding and adding and adding. We will be doing that later, but for now we're just going to be doing is a finite arithmetic sequence. So we know what the end is, the end term. We know what the end term is. Okay, so just quick reminder, like at the beginning of the video, what we had our first term, the common difference, the nth term, and -1. This is a general formula, right? So we're going to use that general formula to determine a general formula for a finite arithmetic series, right? Or series, not a sequence anymore, we're doing a series. So this is how we're going to do it. We're going to say S of n is equal to let's use regular numbers along, so because it's gonna simplify to that anyway. So we're gonna say the first term is 1, second term is 2. This is our common difference here is obviously 1, 3, 4, dot 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 dot. But where's this gonna end? We know this end because the n is gonna be at n, right? And then this term over here before n is gonna be n minus 1. Because at the moment we don't know what n is, but we know that the term before that is just going to be n minus 1, because we see the common difference is 1, right? And then the term before this would be n minus 2. So what we're going to do, we're going to take two of them, and it's the same thing, s of n, but what we're going to do this time, we're going to start with n and we're going to work our way back. So this term would be n minus 1 plus this term here would be n minus 2. This is still the same thing, we're just writing it differently. And then this will come down to 3 plus 2 plus 1, right? Plus 1 looks amazing. So from here what we're going to do is we're going to add the terms that's below it, because you're going to see what it's going to turn out to. So S of n plus S of n is just simply 2 Sn, alright? And 2 Sn is now going to equal to 1 plus n, or another way of writing that is just n plus 1. And then 2 plus n minus 1, minus 1 and 2 makes plus 1, so this will be again n plus 1. And this continues because we have n minus 2 plus 3 is just the same as n plus 1. So we continue doing this for all the terms that is in our series, and then we get to the end here. That notice we have n minus 1 and 2, so we will just get again n plus 1 plus, and the last part is again n plus 1. And how many n plus 1s do you think there is? There's n of them, right? Because look at how we're getting 1, 2, 3 all the way up to n. There's n terms there, so there'll be n plus 1s. So that's the same as writing the spots there stays the same so far because we didn't do anything with it. It's the same as writing n multiplied by n plus 1. Right. So now we want Sn by itself. So we will write this as Sn equals to n divided by 2 into n plus 1. Notice that this is an example for when the difference is 1, right? So if you wanted to count what would be the sum to the point 100, so we'll say S of n is equal to excuse me there. We'll say S of 100 is equal to 100 divided by 2, 100 plus 1. 100 divided by 2 is 50. 101, and that gives us 0505. So if we took the series for where the common difference in an arithmetic sequence where the difference is 1 from 1 to 100, and we added all of them together, we would get 5050. Right, that's where I'm gonna cut it, guys. I'll probably do a part 2 of this next week where we can just continue with the geometric sequence. But yeah, thanks for watching. See you in the next one. Bye.